Hi, I am Muhao. Today I will present our ICASSP work, a virtual-based system with improved overflow control. Virtual-based system is a cycle-acoustics method to enhance the basic performance of small or flat speakers that are not capable of reproducing good bass. VBS can virtually produce a sensation of low frequencies by injecting a series of harmonics. However, due to the arithmetic addition of high-pass filter signal and additional harmonics, there is a possibility of arithmetic overflow at the output signal. In this case, signal components with amplitude beyond digital restricted range are truncated to the maximum positive or negative values. This leads to clipping distortion with harsh sound in the playback. The commonly used method to prevent overflow is to use the limiter, which provides attenuation over the amplitude level that overshoots the threshold. However, there are several drawbacks of using the limiter on the VBS. First, the limiter also attenuates high-frequency components of the VBS enhanced signal that can't be physically reproduced. Second, the limiter effect is highly dependent on the setting of the parameters. In this work, we propose an automatic gain control method, which automatically sets a gain limit to users' selected gain. The computation of gain limit is based on the detection of percussive events of the input signal. Through detection, we find the periods of percussive events that have high amplitude levels. First, we transform the input signal into the HFC function, which produces sharp peaks during percussive components and has been successfully used in the detection of percussive onsets. After that, we detect the onset and offset of percussive events on the HFC function. Now we say the detect. First, we detect the peak frame of HFC, which indicates peak levels of percussive events. Second, we detect onset by finding HFC notch in 15 frames before the peak. Finally, we detect the offset by finding the HFC notch in 30 frames after the onset. In previous work, it is suggested to use the minimum and maximum length of 50 and 200 milliseconds in segmenting percussive signals, which guarantees enough information for the following future extraction. Therefore, our selected period of 197 milliseconds is sufficient to capture percussive events. After the detection, we compute the gain limit for each percussive event. During a percussive event, the gain limit is computed to ensure that the mixing of additional harmonics and original signal does not overshoot the maximum digital range 0 dB. If a gain set by users overshoots the gain limit, the gain for harmonics are fixed to the gain limit for this percussive event. In this case, the overflow is prevented and the gain is maintained to the maximum suitable values. We conducted a test to evaluate the overflow in the VBS. 50 polyphonic mute stimulus with sufficient low-frequency components are used. Each stimulus is 10 seconds long at a 44.1 kHz sampling frequency. We enhanced the stimulus using the VBS with 8 dB gain. In this case, so many overflowed samples is found in the 50 VBS enhanced stimulus. The proposed gain control method requires the detection of the percussive events before applying the gain, and it leads to the delay in the system. Hence, we tested different delay time for the method. The maximum delay time is only 197 milliseconds, with which the overflow can be completed prevented. We found that the delay can be reduced with a very small increase of overflow samples. ITU1359 proposes a detectability threshold of 125 milliseconds and an acceptability threshold of 185 milliseconds for audio-video sync error. Hence, the delay in the proposed method is suitable for application with both audio and video. For the limiter, we tested the 3 thresholds with a typical set of attack and release time. We found that the lower threshold can efficiently prevent overflow, but it also heavily attenuates original signals. In conclusion, We propose a harmonic gain control method to prevent overflow and clipping distortion in the VPS. Compared to the commonly used limiter, the proposed method has several advantages. First, it does not lead user setting, but different parameters lead to different results in the limiter. Second, it only controls the gain for harmonics, while the limiter also attenuates high-frequency components of original signals. Finally, the proposed measure maintains the output at the maximum level, while the limiter may over-attenuate the output level. Thank you.